All right, guys, let's go ahead and do this problem number 2 for an AP mock exam. This problem is designed for 2020 to have multiple parts and take about 15 minutes. This one is definitely simpler and less involved in its answer choice answers and all of that kind of stuff than the number 1 that we had of this exam yesterday. So let's get into it. Yesterday's was pretty daunting. Today I think you'll feel a little bit better about. So here we go. So poke is a bowl filled with various sushi-like ingredients. So we're going to be mixing all of this together. Customers order, they select a large variety, and we're interested in the ingredients that are premium because they cost extra. So when we add it to any bowls. So customers say that may choose as many or none of the premium ingredients as they like. Now, one poke restaurant has tracked the number of premium ingredients that customers chose. So here's the information, and that when they keep track of that, then that's going to help them with their ordering and their profit estimates and all of that kind of stuff. So here's the distribution of these ingredients that they got. So this is called a discrete random variable. Okay, so the reason that it is discrete is because you can see we have a finite amount of options. We have 5 options. They can get 0, 1, 2, 3, or 4 premium ingredients. So discrete random, because we don't know exactly how many, variable. All right, now they have over time calculated these probabilities for those amounts. Okay, and so 0 ingredients 42% of the time, and so on. Now, you want to note that all of these probabilities total up to 100%. So you know that if that's the case, then this distribution is describing the whole population. Because remember, we're always keeping track of, is this population or is this sampling distribution? Okay, that's a very important concept in this class. So here we have our population of data. So let's move on to our question. So here we see what is the probability that a randomly selected customer selects 2 or more premium ingredients, okay? So we're just going to take a look at our items here and add up those ones for 2 or more. So here's what that looks like. We're adding together those 3 probabilities to get 0.25. All right, next. Of course, you would have had to have shown the work and get the correct answer to have full credit on that one. Now, the next one. If a randomly selected customer does select at least one of the premium ingredients, okay? So when I was taking a look at this problem, just as I was reading it, FYI, anytime I get at least one, that kind of rings a target bell, because I always think a probability of at least one is 1 minus the probability of none. So when I see at least one, I'm kind of looking, is that going to be this kind of problem? Well, let's continue. If a randomly selected customer does select at least one premium ingredient, what are the chances that he selects 3 or more? So that's not exactly what I was thinking that our typical probability of at least one problem is asking. This one is saying, given that this person has gotten at least one, then what's the probability that he gets 3 or more? Okay? Now, so let's take a look at our formula chart. Here we have our formula chart, and if we go down here and look at the probability section, see, for our discrete random variables and our probability distribution. This is, since we can use all our notes this year in 2020, I would recommend adding this to your formula chart. Oh, hold on, that's for something else later. I got ahead of myself. But here's what we're looking at here. So we've got, out of all of the probabilities of getting at least one premium ingredient, okay, then notice on top here is not just all of the A's, but that intersection of A and B, meaning they had 3 or more and at least one. Well, in this case, those are the same thing, okay? So let's do those numbers. Here's how that math looks. So the probability of at least one is going to come from these probabilities here. And that totals up to 58%. Everything except for none. Okay, at least one minus the probability of none. See how that's kind of where that's coming from. All right, so we have that 58% is the denominator. And then what we want on top is the intersection, meaning both at least one and three or more. Well, that's the same thing. That's this section right here. Okay, so we want that 11% on top. And so there we go. That's how we come up with 0.897. So you'd have to show minimally this work here, but this helps in you kind of clarifying in your brain what it is that you are doing there. All right, next question says, what is the shape of this distribution? So I was surprised in this problem, FYI, that they went ahead and told us the distribution has a mean of this and a standard deviation of this, okay, and only asked us about the shape. I was surprised that they did not ask us to do the full socks, okay. They do that later, but anyway, that was one thing that was of interest to me. So let's discuss that. Let's come on up here and look at this distribution. Here's the population, okay. So what I'm thinking to myself is, okay, what does this look like? So these are that number of premium ingredients, okay? And then we want that probability, also known as percent, also known as, because we're reviewing vocabulary and stuff, relative frequency. Not just frequency, but frequency relative to the total. That's what makes it a percent. Okay, so we're going to label 10%, 20%, and so on, 30, 40, and so on. And then we've got 0, 1, 2, 3, 4. Because we have just those discrete of items, it would probably be shown on your graph, if you were to graph it, such as this. So here we go. 0 goes up to 42%. So that's going to be something about like, there's 42, and then next would be 33, and then next would be 14, and then next would be 8. I did that too high. And then next would be that 8, and then we would have that that at the end. Now, when I had done my original key, I had drawn it like this. So I had drawn it more kind of like histogram bins. So you could do that in either way. You could have like called these the zeros, and these the ones, and these the twos, and these the threes, and these the fours, because it is discrete. Okay, these bars do need to be touching because it is quantitative and it continues out here. I did mine as, 0 up to 1, looks like that, and 0 up to 2 went there. So those are two ways you could have graphed this if you were asked to. But regardless, here is our shape. There it is. Now this looks like, if you look down at your right foot, here's your toenails. Okay, so here we got our right foot, our right tail, are skewed right. Okay, so we're just going to say down here then, this distribution is skewed right. And it asks to explain how you figured that out. And so a common way that College Board wants the explanation of positive, negative trends, how can you tell if it's linear relation, all these different things, is comparing as one goes up, does the other variable increase or decrease, or how much does the frequency increase, decrease. So I chose to use that language when I described my answer. There is the highest frequency on 0 premium ingredients, context, always, and the frequencies get smaller as there are more premium ingredients. So therefore, I was verbally describing what basically what was happening there. All right, very good. So now let's go on to the next question. The next question says, if 16 customers are chosen at random, Okay, so that means we have a sample of size 16. From all the orders taken on a certain Saturday night, okay, describe the shape of the sampling distribution of sample means, X bars, of the premium number of premium ingredients. Explain how you arrived at your decision. All right, so over and over and over again, one of the key things that I keep seeing is you have got to understand this idea of population. So in our case, remember, our population looked like this, okay? Versus, so these are individual orders, okay? 0, 1, and so on. These are individual orders, population pieces of data. Then we would drop down and we would then do randomly select 16, and what I would get from that 16 is an X bar. That's an average of 16 orders. Here's another average of 16 orders. Here's another average of 16 orders. This is the sampling distribution, not the population. Sampling distribution of samples of size 16. Now, what do we know about sampling distributions of samples of size 16 in attempting to overcome a shape that is not approximately normally distributed? We know that for sample means, in order to be large enough, we need to have a sample size greater than or equal to 30, and this is not. Therefore, while this right skew might be a little less right skewed, okay, let me see if I can find a picture here. I don't have that pulled up. While this right skew might be not so skewed, it will still have that it is not yet achieved approximately normally distributed. And that's the key that they wanted you to have here. So I wrote this way. The shape of the set. So you know what I did? It actually just says describe the shape again and explain how you arrived. I was thinking about just doing the whole socks again, and so that's what I was thinking when I went through here. So let's take a look at that. But I did answer the question they asked. The shape of the sampling distribution of samples of size 16 is still skewed right, but not as strongly as the population. And you know what I did not do that I am now seeing I did not do? Explain how I arrived at that. So I did not address here that that sample size of 16 was not large enough to overcome the problem, and I should have. So I would have gotten marked off. I did not explain why it is still skewed to the right. And so in order to get full credit, I should have said, since 16 is, not greater than or equal to 30, it is not large enough to become approximately normally distributed, and so on. And so that's what you would say here. But you would write this out, of course. Okay. All right. Now, as far as I had also notated, just because I was thinking ahead of the full socks, which you do not have to do this. The center, we don't really know what kind of samples we got and such. We don't know as far as outliers goes. Center, however, formula chart, let's take a look here. If we take a look at the second side of this formula chart for our sampling distribution, and these are for means. So here I come down here. See, look, here I have random variables, sampling distributions for means, and here I have it right here. Okay, we have one mean. So here was, that means our mean of all the X bars. So all of the X bars, well, in this case it was right skewed, but it'll be centered where the population mean was. So we were told in part C, the population mean was 0.97, so this will still be centered at 0.97, okay? And then if you were to do the standard deviation, you would take that population standard deviation they gave us in part C, 1.072 divided by square root of 16. So that would make it less varied than the population, but it is still skewed and centered at about the same location. All right, see, same center, less spread. Okay? All right. Very good. Now let's move on. So this next question says, a shift leader has suggested that she wants to use a random sample from Saturday night to then plan her orders for all of next week. So she wants to base what she orders for what she anticipates the orders to be for all next week. And she does this based on Saturday night. So the question asks us to describe what you think might be a problem with that design, that decision to collect her data on only Saturday night. And then also explain whether you think this decision will result in an underestimate or an overestimate of the number of premium ingredients she will need for that whole week. So this is a sampling method. Okay, do we think that Saturday night results is going to be representative of, indicative of the whole population she wants to generalize to, and she wants to generalize to the whole week? And so that's where this problem comes into play. So what we're going to do is say, I don't think so. And let's make sure then that when we describe this situation, we explain several things, okay? First of all, I explain why I think Saturday night will not provide representative results that are typical for the whole week. And you had to be specific. You had to write out some plausible reason as to why you think that. So Saturday night spending and meals are most likely not the same as all weekday nights. Okay, so I said, number one, that's going to provide different results. Here's why, specifically. People may be celebrating and splurging and buying more premium ingredients. That's why. And then here's now the rest of the answer about over underestimate. Therefore, the Saturday night data is most likely an overestimate. So there I have an overestimate of the buying in a typical week. Okay, so again, three things in a fully processed answer. Saturday night's not representative. Here is why. And because of that specific contextual reason, it's an overestimate of the week's samples needed, or ingredients needed. All right, next. The shift leader isn't done working hard yet. She has calculated that Friday nights typically have 300 poke bowl orders. So now she wants to do some estimating on some profits, okay? So here we go. 300 bowl orders. But we need to then decide, okay, how many premium ingredients that equates to, because we know we get a profit of $2 per premium ingredient. All right. What is the expected profit on a typical Friday night? So this information, by the way, goes to part G, so we'll hold off on that. So let's take a look. When I wrote my answer out, I was very clear in writing units. So we've got units and a change of units from bowls to premium ingredients, and then transform $2, the profit, transforming to profit. So here it goes. Here's how that answer looks. So let's do that and pull that down and see what we got. So the first thing that I did was I said, okay, I need to see how many premium ingredients are expected. Expected value is the mean. So, see, look, here was the mean number of premium ingredients per bowl. So 300 bowls times 0.97 ingredients per bowl makes, on average, the expected value of 291 premium ingredients on average. Now, let's transform into profit. So that makes the profit of, expected 291 premium ingredients on an average Friday night, $2 profit per. So an average Friday night, I would expect there to be $582 profit on average due to premium ingredient sales. Okay, and then that's all that one had asked for. Next is a question then about, I think, some sampling. Oh, okay, looky here. Actually, the instructions for this started down here. I cut this problem and didn't do it in the right place. So finally, a shift leader takes a large random sample. She takes each of 50 weeks of the year. So she did 50 weeks through the year and randomly selects. So would take the orders for one of the week, put it in a bag, shake well, and pull out 2 orders from each week. Okay, so what we need to be doing is thinking, what is that design controlling? What is the purpose of organizing it that way? Does that have a benefit? What is that doing for us? And so on and so forth. So the first thing that we see is describe. This time it does wholeheartedly say to do the entire describing of all of the socks for a sampling distribution. Okay? For the X bars, the sampling distribution of X bars for the premium ingredients for samples of size 100. Wah, wah, wah. Now we have 100, so that should be signaling something to you. So first, here we go. Shape of this is going to be sampling distribution. Samples of size 100 is large enough, greater than or equal to 30, to be approximately normally distributed. So we will have means centered or approximately normally distributed, okay? So now, outliers, I don't know of those because I don't have the data. So then now we have the mean. Okay, remember this right here? We will be centered. The average of all of our X bars will be at the same place the whole population was, which was 0.97. So that is why we have that listed as 0.97 right there, same as the population. The mean of the X bars, you would need to say, I'm saying the mean as opposed to median, same as the population, okay? Spread is the standard deviation. So it will be less than the population. It will be that standard deviation of the population divided by the square root of n, 0.1072. So very much less varied, 10 times less varied. All right, now, next. Name the sampling method that this shift leader used and explain what statistical advantage, what was so good about that instead of taking a simple random sample. So let's think of what happened. They got 100 items in a sample by taking 2 from every week. If we had taken the entire year's orders, put them all in a big bag, shaken well, and pulled out 100 orders, what quality might happen with those random, I could just pull out any 100, and those could have been like all just happened to be in the summer. Those 100 orders could have all happened during COVID-19. Those 100 orders could have all been during the holidays, not spread out throughout the entire year. Okay, so there's a concern. That's where our statistical concern is. Okay, so let's take a look. What kind of grouping is it when we had one for each week? In my WebEx sessions, I got both times people told me cluster. Okay, so let's think about that. Cluster. Hey, cluster, you're a group. I will sample all of you. Hey, cluster. Hey, cluster. Okay, those are our many populations. That would mean we would have all those 50 weeks. We would randomly select one or a couple of those weeks and then sample all in that week. So do you think the orders all in the week around the holidays is going to be the same as the orders all in a week in February or March or something, Even spring break is going to be different than the other weeks in March, I bet. So, cluster, I don't think you can say when you pick a cluster that each week is a mini population. So therefore, it's not that. It's stratifying, and let me remind you what stratified is. Stratify, homogeneous. Every single group is homogeneous. And then I get some of you, and some of you, and some from all of you. I got some from every single week. Okay? from each strata. So therefore, I'm getting a whole smattering throughout the whole year, and I'm making sure that it's representative of all of the year. It's similar to when we did random rectangles, and we wanted to estimate the area of a page. We had all the little, we shook the rectangles so that we had the small ones up at the top and the medium ones in the middle and the large rectangles at the bottom. So therefore, we made sure we controlled, so we got some of the small, some of the medium, and some of the large to make sure we got that full representation of all of the kinds of rectangles, like here, all of the kinds of weeks. All right. The shift leader stratified by week and randomly selected 2 days from each week. Now that's the method. Here's why it's good. And I've been told this is to ensure with an E. This method helps to ensure that the data is more representative of the entire year's results, because, and then you had to make sure you addressed, what could happen bad with a simple random sample. Don't just stop there. Elaborate specifically what could go wrong with a simple random sample. It is possible that a SRS, a simple random sample of all 365 days, you put in a bag and you pull it out, can get unrepresentative times of the year, such as all in the holiday season or all in the summer. Okay, that's the reason. So you needed all of those specifics. Correct name, and that connects the statistical advantage of it being more representative of the entire year, and why simple random sample is not representative of the entire year. Okay? All right, now here we go. Next thing. Businesses on Friday, Saturday, Sundays are very different than during the rest of the week. Okay, so premium ingredient purchases different on Friday, Saturday, Sundays as the rest of the week. Describe and name a sampling method that would adjust for that observation. Control it so that, because even if you did all 50 weeks split up, is it possible that when you take 2 from each week, most of them were Saturdays, or just, a couple of them ended up being a Wednesday? So that could have happened. So if you wanted to make sure you controlled the Saturdays and the weekends versus the weekdays, then you can go further. I had a student describe to stratify by every day of the week. So put all the Mondays in a big bag and all the Tuesdays in a big bag and stratify that way, and then select 1/7 of your sample from Monday and 1/7 from Tuesday and another 7th from Wednesday. I loved it. Mine was not quite as detailed as that. Mine just accounted for what they talked about, Friday, Saturday, Sundays versus Monday through Thursday. So a shift leader could stratify by all of the Monday through Thursdays. So put all of the Monday through Thursday tickets in a bowl, shifts in the year, and then all of the Friday through, this should be Sunday, shifts in the year. So make 2 bags or bowls, Monday through Thursday ones and Friday through Sunday ones. Okay? Then he could randomly select 4/7 of his sample from Monday through Thursday and 3/7 of his through Friday through Sunday, similar to the 1/7 for each day of the week. Okay, so let's see if I did everything. I described the sampling method. I said stratify it by those ways to adjust for that observation, and explain now what statistical advantage created by this model. So let's see if I did that. So here's it is. This would provide yearly results that are proportional to all of those types of shifts that result from the varying days the weeks create. Okay, so this is that explaining why did you do that. It makes it proportional to those 2 types of orders that you need to control that vary. All right, I think that might have been the last one on that. Very good. Okay, so hopefully you can see that 15-minute mock exam problem was not quite as involved as our number 1 problem that we had yesterday, but still lots of details and lots of statistical understanding that we can show through it. Okay, so I hope that explanation benefited you to see the details that you need to include.